Hello and welcome back to Steven with Steve. Today we're going to keep going on with our algebra exploration. I'm going to look at how to multiply and divide terms together. So let's jump on in. Now if you've done the work up to now, hopefully this pattern that we're about to do isn't going to be that much of a leap forward. So there's a bit of a bad meme for you. So I remember when I love you was just algebra. So hopefully you can see that's the same as I less than 3u as well. And yeah, let's jump on in. Here we go. So what's a more powerful way of expressing 2 plus 2? Well, hopefully you remember your times tables, so you can also say that as 2 times 2. And then there's another more powerful way of expressing that, which is then 2 to the power of 2. Now I say that's more powerful because it allows you to represent a larger number really quickly. Because 2 to the power of 2 is still the same sort of level down there, but if we change the numbers around, and we use 9 and 80. If we did 9 plus 80, that just equals 89. If we did 9 times 80, see how it's getting a bigger number? We get to 720. And then lastly, if we did 9 to the power of 80, that equals that ridiculously huge number there. Right? So by writing with 3 characters, do you see I've written a huge number, but I've made it in a nice compact way. So when we say things are more powerful, it's basically the ability for it to express larger numbers quite quickly. So when we multiply terms, we need to understand the first step, and we need to solve the numbers part first, and then we need to group the variables by either making them bigger or smaller using powers. Okay. So for example, if you have a times a, that doesn't just equal a. That's the main concern here. So a times a equals a squared. So you're going to have a really big expression like this, and instead of writing that, we want to be able to make it as compact as possible. So then it makes it easier for when we write it and use it in other equations later down the track. So this is really, really important that we make it as compact as possible. So first example, if we had 6 times a times b times b times b times b, we could write that. That's totally valid. But a better way of doing that is to make it compact and group the numbers. So the 6 is by itself, the a is by itself, and then the b to the power of 4. So it's not b times 4, it's b to the power of 4, because it's slightly different. So if, for example, we made b is equal to 3, b to the power of 4 wouldn't equal 12. B to the power of 4 would be the same as 3 times 3 times 3 times 3, which actually equals 81. So first challenge, have a go at that, see if you can do it. Awesome. So hopefully you picked up, there's the 4. How many C's? You just group all those together. And notice that I'm keeping this in alphabetical order. So that's C to the power of 3 and then D to the power of 2. So in the next example, we want to try and simplify something like this. So we're going to have fractions and division involved as we go through this. So 4 divided by 12. We can divide the 4 and the 12 both by 4, and we can be left with just a third. Now if we throw algebra into the mix and we put a P and an S in there, you need to be able to cancel out the tops and the bottoms out. So in this case here, you can divide the top and the bottom by 7, and then you just live with a P in the top and then 3S on the bottom. So just pause the video, have a go, see if you can do these ones in your books by yourself. Okay, so for the first one, you would have 7 times 2 times 3, which gives you 42, and then you just group the letters in order, so A, B, C, D. The next one, then you've got 3 times 5, which gives you 15. Then there's an x times x, which gives you x squared times y times z. The next one, 10 and 15, can be both divided by 5. So you get 2 and 3 on the top and the bottom. And then there's a b on the top and the bottom, which cancels out. So you're left with 2a over 3c. And the next one here, you can divide them both by 2. So you get 9 on the top and 8 on the bottom. And then you cancel out one of the x's and then leave the y and leave the z. Cool. So this one here, you've got 5 times 3 times 2. So we group the numbers first. We get 30 ABC. Have a go at this one here. So just pause the video. Awesome. So we do 5 times 2 first, which gives us 10. Then we've got an A. We've got another B on top of the B to the power of 4. That then gets us to B to the power of 5. And then C to the power of 3. So just pause the video. Have a go at these guys. So the first one is just the same as 3xy. The next one then becomes 5abc. The next one then becomes 63d. And the next one becomes 10ad. The next one we can group down, so we can divide both the top and bottom by 5 and cancel out the a, and that gives us just a half. And the next one we can divide the top and the bottom by 7, so we're left with 1 and 2, but then we're just left with the x and the y on the bottom. Next example, so we've got negative numbers now. So we can have negative 2 rq times 3q. So the first step, a negative and a positive makes a negative, and then 2 times 3 becomes 6, and then rq squared, because there's 2 q's. Have a go at that one. So the first step is the symbol, so negative and negative becomes a positive, then 9 times 3 gives us 27, and then a times a gives us a squared, and then b, and then a c. So just pause the video, have a go at these guys. So the first one, 3 times 8 is 24, ABC. The next one is a squared. Next one is 8x squared yz. Next one was 8, a squared, b squared, cd. Next one cancels out and we're just left with x on 3. Next one was 1 on 6x. Next one was negative a over 2b. And the last one, we've got negative p over q. Notice that I've brought the negative symbol up to the top. So that's really important for future things. Okay, so instead of leaving the negative down the bottom, try and bring the negative up the top if you have the option. So example number 6, here we go. We've got 3x divided by negative 6. Hopefully we've picked up the pattern. You can divide both the top and the bottom by 3. So you're left with negative x on 2. So just pause the video, have a go and see if you can do this one. So you should see that we've got a negative and negative, so that makes a positive overall. And divide the top and the bottom by 5. And then one of these q's can be cancelled on both the top and the bottom. So you're left with just 3 on 5q. It's a little bit more complex. We're going to get different shapes. So if we want to write an expression for this, we know the area of a rectangle is length times width. So we can fill in the blanks. So we can go area is equal to 6r times 4r, which then gives us 24r squared. So depending on whatever r is, we can sub that in and it automatically work out the area of this shape. So just pause the video, see if you can have a crack at this one. A little bit harder. My hint to you is to try and substitute values in around the corners. So the first one, I would break it down into the two shapes. So I've got area 1 on the top and then area 2 down the bottom. I've got 7a on the top, 5a there, 2a there, and then, yeah, let's just work out the area. So the area of the total, notice I've used a little subscript here, is equal to area 1 plus area 2. So area 1 is 7a times 5a, which equals 35a squared. Area 2 equals 2a times 2a, which gives us 4a squared. Then area total equals 35a squared plus 4a squared. And notice the a squared are like terms because they're exactly the same. Now if this was just an a, no, you couldn't add them. But because they're both a squares, you can merge those together and get the area total of this shape is equal to 39a squared. So if you change the value of a from 1 to 2, all those different things, you could go through and work out all this, or you can just sub that into that one equation and get the answer straight away, which is pretty cool. So let's have a go at these ones. So express the following, just pause the video to see how you go. So with the first one, x divided by 3 is just x on 3. Next one is m on n. The next one we can just simplify that down to 4a. The next one we can divide the top by 4 and the bottom by 4 and then take out a b, so we're left with a 3b. The next one, 4b times 2a is length times width, which then gives us 8ab. And the last one is equal to 24x squared. We're going to quickly do some problem solving now. So move into this one. So a box has a height of x centimeters is 3 times as wide as it is high and 2 times as long as it is wide. Find an expression of the volume given the box. So the volume equals length times width times height. Pause the video, see if you can do it. So the first thing I would do here is draw a quick little box, and then we go height is equal to x, width is equal to 3 heights, which then is the same as 3x. So you can put 3x there, and then the length is equal to 2 widths, or 6x. So now we just substitute that into the volume formula. And notice that we've got the same variable all the way through. So the volume is now equal to x times 3x times 6x, which then gives you 18x. So if we wanted to make x equal to 1, we could quickly find the volume of that particular proportional rectangular prism. So that's it from me. There is a Dr. Frost there for multiplying and dividing terms. That will help getting you set head in the game for this, which will help for the upcoming exam. So hopefully you've enjoyed this algebra exploration. If you have, please give us a like and subscribe down below, as it does help with that YouTube algorithm. And yeah, see you next time on Steam It with Steve. Adios.